So let us see how these simple experiments of intermediate first year physics students will be demonstrated using these virtual laboratories. The first one is your Vernier calipers. Okay, so when you have this Vernier calipers here, make use of these virtual laboratories to simulate a few simple experiments. So the first one being the Vernier calipers. You can just click on this. Click on this, it will open a door for your Vernier calipers here. So this is your simulator. This is your main scale Vernier scale, which you already studied in your theory classes. This is only demonstrating you how to make the measurements. You can measure the diameter of the sphere. Say automatically the jars get adjusted. You would adjust like this. Note the main scale and Vernier scale readings. Similarly, if you are taking this, if you are making length, the position will be like this. If you are taking the breadth, it will be like this. And if you are taking thickness, say automatically the position is getting adjusted. You adjust the jars in such a way that it will allow you to take the measurements. You can check the value, or I have created an Excel sheet here to determine the length, breadth, diameter, internal radius of the given objects. So suppose you have taken the cylinder, the diameter, main scale reading is this, Vernier scale reading is this, Vernier scale linked to least count. When you calculate and do this, this is how you are getting. So that's how you will be doing. Similarly, you can reset it, and then suppose you take a beaker. Internal diameter, the upper jars, automatically it is inverted and kept here. You can measure the same position, same way, but you will be taking the readings of the upper scale. And suppose you want to measure the diameter, the depth, this is a middle rod, it will be inserted and accordingly it will be taken. Like this, you can measure other experiments you can do, say Ohm's law. Suppose you have this experiment, you can verify Ohm's law using this experiment. If you are not sure, the circuit will be shown like this for you. All of them are in series. Ammeter to battery, positive, positive, negative of the battery to the key to rheostat, rheostat to the resistance, resistance back to ammeter. Ammeter is always connected in series, a voltmeter in parallel. You can vary the resistance of this rheostat, measure the voltage and current, calculate the resistance. So you can select the metal. This is the wire whose resistance you are finding. It can be made of silver, it can be copper, so you can change, copper is changed, or it can be gold, now it's gold. Aluminum, as you change, this material also appears to be changed. This is iron, this is nichrome, this is stainless steel. Let me take gold. So once again, length of the wire also can be changed. You can change the diameter of the wire. You can change the resistance of the thermostat. So convenient value you take. Okay, and if you are not sure of the circuit, once again you can click here and take. So ammeter to the battery, battery to the rheostat, battery okay, we'll come back. Rheostat to this to this. This has to be brought here between these two. Okay, and then key, change the battery to key. Okay, close the key. What is it? It's giving you voltmeter value. You can enter the value here, 0.689. Current is 9.311. So this is how the resistance is calculated. Then show the result. It will give you resistivity of the wire. The wire is not changed. Then reset it, and then resistance, it was 20. Now let me take it to, let us say, 30. Okay. Connect the circuit once again. These two, key to rheostat, rheostat to ammeter. Close it, bring this here. I've taken silver now. Okay, length, diameter of the wire also can be changed, or it can be remaining the same. So close the key. So now you enter. You say add, then the other column will be added here. 0.017, 0.017 is the voltage. The current is 0.33. So this is how you will be doing this experiment. Then comes your, it's a simple pendulum. Simple pendulum. So you can have different planets, you can do this experiment. You can have a protractor, Earth, Moon, steel, copper, say it's changing. Brass, for a change let us take lead. Let's take brass. You can change the diameter of this rod, keep it at a convenient value. You can have the protractor. So measure the length you can change. It should be more than 5 degrees. Start it. Find out the time taken to complete 20 oscillations and say stop. Pause it. So you have to measure the length and the time taken. Record your observations here. This is a screenshot. You can vary the length between 5, 10, 15, 20 and so on. Measure the time taken for 20 oscillations. Trial 1, trial 2. Take the average. Find out the time period and L by T square. Find the average L by T square. Once you know that, you can calculate G is equal to 4 into 3.14 into 3.14 into L by T square. This is how you will be measuring the radius. Acceleration due to gravity. Okay. Then comes another experiment, verification of Hooke's law. Verification of Hooke's law. So this is how I have already done this experiment. You have to bring all these weights here. This is a spring. Force is directly proportional to the displacement, and the constant of proportionality is called that swing constant, K. F by X is equal to K. You are verifying that. So you will be pulling all these values here and it will be displaced. There is a scale attached here. By keeping this weight hanger here, you will be pulling the spring and the amount of elongation is measured using this measuring scale. Tabulated here, you can plot a graph between these two. So how are you doing it? So once again, bring the 2 kgs here, 1.6. So bring 5 kgs. You can enter the new values also, or whatever values are there. We have done this experiment. You can See once again, maybe it is 3.9 second time. Okay. Then you pull 8 kgs. This is now 6.3. Okay. And then now bring 10 kgs. So maybe it is 8. Plot. You can also have your Excel sheet created like this. Enter the values and do this. Then you have a compound pendulum. So common balance. So you can open the door, keep whatever bob you want, keep the weight roughly, close the door, so accordingly it changes the weights. Okay, open the door, remove all the weights. You can say reset. If you reset, everything will be gone. So before you make any measurements, you must find the zero resting point. So close all the doors. See how many turning points on the left, turning points on the right. Take the average and find out the turning points. Left 3 turning points, right 3 turning points. Find the average of this, find the average of this, find the resting point, and accordingly do the calculations. So this is how you will be doing different